Hello everyone, I welcome you all again on this lecture series on transportation engineering. This is lecture number 20. In this lecture, we are going to study the problems, the conceptual problems or the numerical problems which we have seen in traffic engineering portion. In this lecture, I want you all to solve the questions with me, and if you face any problem, you can write in the comment section, in chat box or in the Telegram group. So let us start with the problems one by one, and we'll discuss all the concepts related to these problems. So this is the first question. This question says, here is a relationship given. This relationship is u equal to 55 minus 0.44 times k. What is u? Here it is said that u is the speed in kilometer per hour. Okay. We have the k, which is density in vehicle per kilometer. Fine. Now this question wants us to find out the maximum flow value in vehicle per hour. Okay. From this question, we can say that this problem is related to flow, density and velocity relationship. We know the flow density and velocity relationship, the characteristic or basic equation is given by q is equals to k times u. It may be u or v, the representation can be different, but as per the question it is q equals to k times u. This is not maximum flow. We know this is the flow for this given density and velocity condition. So we can create, as in the question we have a relationship between u and k. In order to bring this relationship in terms of flow, we can bring this u equation here. So we can write q is equals to k times this equation. We have replaced u with the relation. So now we have this equation. We have q or the flow value in terms of density is 55 k minus 0.44 times k square. We have seen in order to find out maximum flow, we have to maximize this equation. How we will maximize this? We will differentiate this equation. Let us differentiate this equation. dq by dk in terms of k, we can differentiate it. This is 55 times k. This is differentiated as 1 minus 0.44 times 2k. And after differentiation, we will put this value equal to 0 so that we can find out the value of k at which the flow value will be maximum. So with this equation, we will solve for k. Let us solve. We will bring this value to this side. Let us write it as 0.88 times k is equals to 55. Now k value is equals to 55 by 0.88. Let's solve this. It is 62.5. The k is vehicle per kilometer, so we will write here as vehicle per kilometer. Now this is the value for which this equation will give the maximum value. Let us write this equation. Q is equals to 55 times the value which we have found, 62.5 minus 0.44 into square of 62.5. Let's solve this equation. This is 55 multiplied 62.5 minus 0.44 multiplied by 62.5 whole square. So the value which is coming out is 1718 0.75. This is vehicle per hour. So this value is your answer. This is Q max. We have the option A as 1718, which is nearest to our solution. If you look at this equation, U is equals to 55 minus 0.44k. Does this equation remind you of the green shield equation or green shield model? What was green shield model? Green shield model says any velocity will be equals to flow velocity minus ratio of flow velocity with jam density into a particular density at which you want to calculate the velocity. So this was your green shield model. So as per the green shield model, if we compare this equation with green shield model, we can say that, or let me write the equation just beneath. I can say that this 55 or 55 value is your free flow speed for this particular section. So we can say that the free flow speed is 55. So if we have this free flow speed as 55, here we can say that the ratio of free flow speed with jam density is equals to 0.44. While we compare these two equations, if Vf by kj or free flow speed divided by jam density is equals to 0.44, we can calculate the value of jam density as we already know the value of free flow speed. So let us demarcate space here. Let us solve these equation in another way. We will find out the value of kj, that is equals to Vf by 0.44, and this is equals to your 55 divided by 0.44. The value which will come out is 125 vehicle per hour. So this is the value which is the jam density. Now from solution of green shield equation or green shield model, we know that Q max or the maximum flow is possible at a density which is equal to jam density by 2, or this will be possible at a velocity free flow velocity by 2, and the value is equals to kj by 2 multiplied by free flow velocity by 2. Let us calculate using this method the value of maximum flow. Your kj value is 125 by 2. Now you can compare the k which you calculated here. This is 62.5, and what kj by 2 is, this is also 62.5. Here we said that the maximum flow will occur at this value of density, and we know that the maximum flow occurs at kj by 2. So we know that this is kj by 2, the value which we have calculated here. What is free flow speed? This is 55 by 2. Now let us calculate 125 divided by 2 plus 55 divided by 2. Oh, sorry, multiply. The value which is coming out is 1718.75 vehicle per hour. So these two values we can compare. We have calculated these two values by different approaches. If you find any question related to this equation, you can solve this equation or this question by any of the means. You have been asked for maximum flow. There may be a condition where the questioner may directly ask you for 1 mark what is free flow speed by giving this relation. You can say directly the free flow speed is 55 kilometers per hour. With this relation, he can ask you what is the jam density. You can directly say using this value 125 vehicle per hour is jam density. So this is a equation, a solution which is asked many times in GATE examination. Let us see next question. This is a similar question and the similar concept is required to solve this equation. I want you to solve this question by yourself, by both the methods, and compare the solution. I want you to write the correct option in the comment box. And if there is any error or any problem in understanding the concept, you can ask me directly. Pause this video and note down the question, solve it, and write the solution in the comment box. Let us move on the third question. This is the third question. It is a very easy question. What does it say? It says it was noted that on a section of road the free flow speed is 80 kilometers per hour. Okay, we have the value of free flow speed and the jam density. The jam density was 70 vehicles per hour. This is not density. The here I think there is error. It is 70 vehicle per kilometer. Because if it is jam density, it should be represented in terms of vehicle per length. So this is vehicle per kilometer. What is asked? They are asking the maximum flow value in vehicle per hour. So they are asking about the capacity. Maximum flow is the capacity. So let us calculate maximum flow. As we have already discussed, the maximum flow is equals to multiplication of half of jam density and half of free flow speed. Your Q max will be equal to 80 by 2 multiplied by 70 by 2. Let us calculate the answer. It is easy. This is 40, this is 35. 40 multiplied by 35, you can write it as 140 and one additional 0 vehicle per hour. So 1400 vehicle per hour. This concept is already we have covered in your first question. Let us move on to the next question. Okay, this question is, I think, is a very important question because Greenberg's model is not asked quite often in your GATE examination, but this model is very important, and the another model which we have studied with Greenberg's model, that should also be covered by you. What does this model says, or this question says? On a highway, the speed density relationship follows the Greenberg's model. Okay, the speed density follows the Greenberg's model. Okay, we are fine with this. When the highway is operating at capacity, highway is operating at capacity. What is capacity? Capacity is maximum flow value or maximum volume. If the highway is operated at maximum capacity or at its capacity, the density obtained as per this model is, they are asking about the density value. Let us write what Greenberg's model says. We'll utilize this space. So let us start from here. Greenberg's model, what does this say? It says your velocity at any flow condition equals to your free flow velocity, that is your V naught, or we can write it as Vf times natural log into jam density divided by the density at that particular instant. So this is the Greenberg's model. This Greenberg's model defines the velocity value in terms of density, and the constants which are used are free flow speed and jam density. If the value of density is equal to jam density, if the value of density is equal to jam density, this value will be equals to 1 and log 1 is equals to 0. The velocity will be equals to 0. If your density is 0, means the vehicle are running with free flow speed. If the vehicle are running with free flow speed, this value will be infinity. And if it is infinity, this value will be, the V will be equals to V naught. But we have seen infinity value, the curve which is given for Greenberg's model is something like this. It touches your speed axis at infinity value of speed, at infinite value of speed. So density will be 0 at infinite speed. So from this equation, they want to ask the highways operating at capacity. They want to ask us about the maximum flow value. We know that the relationship between Q is density multiplied by velocity. We can write the Q value as density multiplied by free flow speed into natural log jam density by the density at that point. Now let us solve this equation by differentiating the flow value in terms of density. In order to calculate the maximum maximum flow value, you should maximize this equation. Let us differentiate and calculate the value of K, for which the capacity or the flow value is maximum. So let us differentiate it. Before differentiating, let me move it, and let us write this Q value as K V naught. I am using the operation for log. The operation is log, natural log x by y can be written as log x minus log y. So I'm using this operation. We can write it as log kj minus log k. Again, make these individual equations. K times v naught natural log kj minus k times natural log k. So this is the equation. I hope you can understand it. Here, this first part of the equation, k is the variable. These both terms are constant. In the second part, both the terms are variable. Now let us differentiate it. dq by dk. Differentiating. When we differentiate this value will remain same. V naught natural log kj. The k value will disappear because differentiation of k in terms of k will be equals to 1. Now this differentiation will be differentiation of xy. So we can write it as x dot differentiation of y minus y or plus y dot differentiation of x. So in this equation, we will do the differentiation in this way. So for this, k will be written as it is, multiply by differentiation of log k, this is 1 by k, plus log k as it is, differentiation of k, that is equals to 1. This is the equation which we get after differentiation. So this is v naught. Here will also be, there will also be a v naught, because after opening the equation we have one v naught here also. We have one v naught here with this equation. Let us put this equation as equals to 0. We'll start here again. If this equation is 0, we can directly put v naught in this side. V naught will be equals to 0, or we can, v naught can be sent to right hand side. The equation after opening these 1 minus log a. Let us again simplify this equation. I will send minus 1 on this side. I will be left with kj minus log of k equals to 1. It was minus 1, here it will be plus 1. This, how we simplified it, we will again go back to the same condition. Natural log kj by k is equals to 1. We know that in order to remove this natural log, we have to put the exponential term on both the sides. Kj by k equals to exponential power 1. We want the value of k. We want the value of density for the capacity. So we are maximizing it. So we need to calculate the value of density. So k here is equals to kj by e. This is the final result which we get after this complete process. Let us go back and discuss this again. What we have done. We know this is your Greenberg's equation in terms of free flow speed, jam density, and density at the particular position. The velocity is given. We know the flow is equals to density into velocity. We have the equation of velocity here. We'll put it, and the complete equation is given here. Now, in order to find out the jam density, in order to find out the flow value, the maximum flow value, we have to differentiate it in terms of density, because we need to find out the density at the capacity level. So we are differentiating the flow equation with the density term. So this is the differentiation. After the differentiation and various operations, we will definitely find out this equation. I want you to again try this problem, and this is the solution of this question, kj by e, which we have found out. Now I think there is no problem from your side in this equation. There's another model which you can try for the same condition. Let us move on the next problem. This next problem is also seems to be on the same flow, density, and velocity relationship. This problem say that on an urban road, the free mean speed was measured as 70 kilometers per hour. Okay, this is the free flow speed. and the average spacing between the vehicle under jam condition is 7.0 meters. The space flow density equation is given by this value. The Q value is K into U. This we already know. They want us to calculate the maximum flow per lane for the condition. For jam condition and free flow speed, they want us to calculate the maximum flow. Do we have this density here? We know that this Q is equals to U times K. U is your speed and K is your density. We also know that Q max is equals to U free flow divided by 2 multiplied by K J by 2. In order to calculate this Kj, what we need, we can calculate K as 1 divided by space headway. We can calculate K as 1 divided by space headway. Space headway, if it is in kilometer, we need not to change it. If it is in meter, we will multiply 1000 in numerator so that the denominator is changed in kilometer. Here the value is given in meter. We will change in kilometer, that is 7 divided by 1000. This is 0.007 kilometers. So from here we can calculate the jam density. It is 1 divided by 0.007. Let us calculate the jam density. We have the value of jam density as 142.86 vehicle per kilometer. If space headway was in meter, we would have written meters in the denominator. But the jam density is here, the velocity is here, we can write it in the equation. Q max is equals to 70 by 2 multiplied by 142.86 by 2. Let us calculate it. The value is coming out to be exactly 2500 vehicle per hour per lane and so on. This is given here, but the jam condition is given. It is for one lane because it is for vehicle to vehicle, bumper to bumper traffic. So the value or the answer is 2500. This is how you can calculate. So these questions will tell you how the question can come from these relationships, these models. The next question is kind of theoretical question, and it is based on OND study. The question says that in desired line diagram, what is desired line diagram? If we have a origin and a destination, starting point and end point. If these are three routes, we draw number of trips between these two routes, or sorry, between these two locations from each route, and you know that the route or the thickness of this desired line is equals to the total number of trips between these two points or between these two locations. Whichever route is having the most thickness or maximum or the thickest desired line will be having the priority or from the commuters. This is desired line. So the question is asking about what a desired line is. Let us read the options one by one. Width of desired line is proportional to the number of trips. This is really true. There is no problem. The width of desired line is proportional to the number of trips in one direction. No, this is not true. It is not in the one direction. It is the total number of trips between these two locations. If this is a residential zone, This is a commercial zone. There will be trips in the morning from residential zone to commercial zone. But in the evening, the same route is decided or chosen, or there may be condition where another route is chosen for commercial zone to this residential zone. And the total number of trips which are made in the day from one zone to another or from another zone to your first zone, that will be equals to, or that will be counted in the width of desired line. So the second option says the length of desired line is proportional to the number of trips in the both direction. The length of desired line has nothing to do with the trips. So this option is wrong. First one was also wrong. Third option says the width of desired line is proportional to the number of trips. True in both directions. This is also true. So the final true definition of desired line is this. A desired line is the proportion or is proportional to the number of trips in both direction. The final option says both length and width of desired line is proportional to the number of trips in both direction. This is wrong because length has nothing to do with your thickness of your desired line. Let us see next question. This is a match of the following type of question. These questions are readily asked in GATE examination. Now, here in the list 1, this is your list 1, this is your list 2. List 1 is traffic surveys. We have spot speed survey, traffic volume survey, O&D survey, and parking survey. List 2 tells you about the instruments which are being used in these type of surveys. So one by one we'll talk about the survey and we'll discuss the instrument which can be used in order to perform that survey. So first, spot speed survey. In spot speed survey, we will measure the speed of a vehicle at a particular section. And we know that measuring the spot speed is done by your Doppler's radar. Your Doppler's radar or your speed gun is used to measure your spot speed. So your spot speed is matched with your Doppler's radar. Then we have traffic volume study. Traffic volume means number of vehicle passing through a section for a particular time. So in order to count the number of vehicle, we use the best method out of tape, interview, or pneumatic tube. The pneumatic tube is the best method. We have discussed this pneumatic tube briefly in our traffic volume study, not briefly. We have studied this exclusively. When we studied, if we use one pneumatic tube or we use two pneumatic tube, we can even count the number of vehicle, the type of the vehicle, the direction of the vehicle, the speed of the vehicle. These many parameters can be calculated using pneumatic tube. Then about O&D survey. O&D survey is done using roadside interview, because parking study cannot be done by roadside interview. This is better matched your roadside interview, and the parking studies is matched with your videotape. For A it is 3, these two options can be correct. For B it is 4, so this option is correct. C it is 2, so this is correct. For D it is 1, this is correct. So for option C, all the list 1 items are matched with list 2 item. Let us move on to the next question. This question we have studied in our classroom whenever we were discussing the parameters, the applications of speed. Not in the form of question, but in the form of discussion. We have already done these questions. So let us see this question. This question says, first is list 1, this is list 2. In list 1 we have speeds, in list 2 we have application of these. The first one is space mean speed, and here we have one traffic flow studies. We know traffic flow Q is equals to KV, and we know that this V is space mean speed. So we can connect with traffic flow studies. I think this is the best match, but let us go ahead and see whether if there is another match for traffic flow studies, we'll look into this space mean speed again. Next is journey speed. Journey speed is, if we are starting from A reaching B, it includes the running time plus your stopping delay between 2 points. So these are the things which we can calculate from journey speed. So can we imagine or can we assume the road condition from journey speed? No, because there may be stopping delays, lot of stopping delays because of the congestion. It may be due to road condition and it may not be due to road condition. So this is not applicable for road condition studies. Regulatory measures, there may be regulatory measures, but for journey speed we don't know why this stopping delay is, whether there is a stop we want refreshment. It is nothing to do with regulatory measures. We can do delay studies if we know what type of stopping delay it is. If it is for refreshment, there is no problem, but if it is for some congestion, we should remove this congestion. So this can be done using delay study. So journey speed is matched best with delay study. So these two options, B with 4, can be take as correct. Then your running speed. Now we can say that if running time is more, then road condition is not good. If running time is less for the same duration, road condition is good. So this can be done. We can match running speed with road condition. So for C is correct. C is, oh sorry, 1 is correct. For C, 1 is correct. These two are correct. Let us see spot speed. Spot speed is the speed at any location. If there are higher speed at any point, we can impose restrictions there. So spot speed study can be used for regulatory measures. It can be used for regulatory measures. So spot speed is matched well with regulatory measures. And the last one which we left earlier, space mean speed, we can see that it is well matched with your traffic flow studies. It is matched with traffic flow studies. This option is correct. If you see this kind of question in GATE examination or any other examination, you can easily solve it by this method. Now this is a numerical problem. It says in a speed and delay study, what is speed and delay study? This kind of study is done using floating car method. I think you remember floating car method. So let us see what question says. If the average journey time on a stretch of road is 3.5 kilometers, we have stretch of road 1 and 2. The distance between these two is 3.5 kilometers. Total journey time, this is average journey time given is 7.55 minutes. The total journey time from here to here is 7.55 minutes. It is said that the average stopping delay is 1.8 minutes. So we can say that running time is equals to journey time minus your delays, stopping delays. You can calculate the running time. Let us see what they want us to calculate. They want us to calculate the average running speed. Okay, now if we calculate the running time, we can divide it by the distance. We can easily get the average running speed. So let us perform this. 7.55 minus 1.8, this is equals to 6.75 minutes. Let me check again if this is true. This is 5.575. This is 5.75 minutes. Okay, so we can calculate running speed as 3.5 divided by 5.75 minutes. The speed will come out in kilometers per minute. So let us multiply with 60 minutes so that we can get speed in kilometers per hour. So the speed is 36.52 kilometer per hour. The nearest answer is A. This is a very easy question. If you find this question is in 1 mark, you will easily score 1 mark out of this calculation. So next question says, which one of the following correctly represent the time mean speed? What is time mean speed? Time mean speed is the average speed of vehicle for a particular time. This time mean speed. This is your time mean speed. Average speed of the vehicle on a road length particular time. I think you are more eligible to answer this question. I want you to read out the problems and mark the option, the correct option in the comment section. Let us move on another question. The roads geometric in India are designed for, so they are, there is some error. Traffic speed, because there is no option which is telling us the 30th hourly volume. If a question comes that the road geometry in India is designed for which volume, if they are asking in terms of volume, the answer will be 30th hourly volume. The volume for which or which is exceeded 29 times in a year. Only 29 times in a year. That is your 30th hourly volume. But this 90th highest hourly or 50th highest hourly, these are the traffic speeds. And we know that the geometric design for Indian roads is done for 98th hourly traffic speed. 98th hourly traffic speed. The imposed speed or the speed restriction is 85th hourly. 50th hourly is the median speed or the speed which is having maximum number of vehicles running with. And 15th hourly speed is the lower restriction, because the slow moving vehicles may impose danger for the moving traffic or they may create a congestion condition. So these are the different speed which can be asked. The question can be changed, the option will be same. If it is asked the design speed, this is your design speed. This is your design speed. If speed restriction is asked, this is your speed restriction. If the median speed is asked, this is your median speed. If the lower speed restriction is asked, this is your lower speed restriction. So all these options are somewhere related to your traffic design. Next question. This question says, if the normal flow on two approach road at an intersection are respectively 50 PCU, 500 PCU and 300 PCU per hour. The saturation flow are 1600 PCU on each road, and the total lost time per signal length is 16 seconds. Then the optimum cycle time using Webster's method is okay. So this is question about signal timing. And the method which we need to use is Webster's method. We need to use Webster's method. Webster's method says the cycle length C is equals to 1.5 times L plus 5 divided by 1 minus Y. This Y is YA plus YB, the proportion of traffic in A direction and proportion of traffic in B direction, where YA is the traffic flow in A lane divided by the saturated flow at A, and this YB is the traffic flow in B direction divided by saturated traffic flow in B direction. Let us calculate YA and YB. We have QA as 500 PCU per hour, S as 1600, similarly QB 300, SB 1600, because it is given on each lane. Okay, so let us calculate YA and YB, and let us write the value of Y. YA is 0.3125 plus 0.1875. अगर आप इनको add these, you will find 0.5, this 0.5. Let us write 0.5. The L value is given. The total lost time per signal is 16 seconds. So we have C equals to 1.5 into lost time is 16 plus 5 divided by 1 minus 0.5. Let us calculate it. The answer is 58 seconds. Yes, we have the option here, 58 seconds. Go through the question again. Try to solve it by yourself. Next question says, an observer traveling at a constant speed of 70 kilometers per hour with a traffic stream over a length of stretch 5 kilometers passed by 17 vehicles more than what he passes. Reading the question, this seems to be floating car method, in which one of the observer observes the number of vehicle overtaken by the test vehicle and the number of vehicle which are overtaking the test vehicle. So the first line itself tells us about the past vehicles and the vehicle the test vehicle is passing. When the observer travels against the stream at the same speed, the number of vehicle he meets is 303. Okay, they want us to calculate the flow of the traffic. Fine, we have the flow value from the floating car method as x plus y divided by ta plus tw. What is x? If you are moving in north south direction, let us say, x is the traffic in north south direction when test vehicle is running in south north direction. This is what he is saying. When the observer traveling against, you want to calculate in north south direction, but the observer is traveling in south north direction. The stream at the same speed, the number of vehicle he meets, means coming from opposite, means coming from north south, is the value x. So we have x value as 303 plus. What is y? Number of vehicles overtaking test vehicles minus number of vehicles overtaken by test vehicle. So we have total number as 17. So we can write it as 17. Now what is TA? TA is whenever you are traveling against the speed, against the traffic, means whenever you are moving in north south direction. We know that the stretch is of 5 kilometers and the speed with which we were moving was 70 kilometer per hour. So we will get the value in hour. Let us change this value in seconds, multiplied by 3600. Okay, we need this value in hour only. So there is no need to change this value in seconds or minutes or whatever. The value is 0.071 hour. Similarly, TW is, this is south north. Whenever you are traveling against the flow, means whenever you are traveling north south direction, this is traveling with the flow. Whenever you are traveling in south north or southwest direction or south north direction, this is traveling against the flow. So you are traveling with the flow in south north south direction. This is also same, 0.071 hour. Let us write 0.071 plus 0.071. Let's calculate. The answer is 2240 vehicle per hour. We have the option here, 2240 vehicle per hour. So this is floating car method. You are asked about Q, the flow of the traffic. You may be asked about the average time or average delay. This equals to TW. You know the equation. Average delay is TW, total time taken minus the lost time during the traffic flow. So this question can also be asked with these values. Calculate the value of lost time or the average delay and write in the comment section. We have question 14. This is from traffic signals. The question says the lost time due to starting delay on a traffic signal is noted as 3 seconds. We have read this curve was time per vehicle. First vehicle was taking time more, and then all the vehicles later on, first vehicle, second vehicle, third vehicle, this is the extra time taken by these vehicles, and other vehicles were taking time equals to the headway. So the total time, this is summation of E, is equals to ES, sorry, 3S, 3 seconds. The actual green time is 25 seconds. The yellow time is 3 seconds. How much is the effective green time? This we know. This duration and this duration is applicable as green time when we are allowed to move in the intersection. And this is the time lost from this duration. So we have effective green time as 25 plus 3 minus your lost time. This is 25 seconds. So this is your answer. Now this question says a single lane unidirectional highway has a design speed of 65 kilometers per hour. Okay. The perception brake reaction time. So it is talking about the reaction time of the driver is 2.5 seconds. Okay. The average length of the vehicle is 5 meters. Okay. Length of wheelbase of a vehicle is 5 meters. The coefficient of longitudinal friction is 0.4. Fine. Is 0.4. It is asking about the capacity of the road in terms of vehicle per hour per lane. Okay. It is asking about the capacity, or you can call it Qmax. So we know that Qmax is equals to 1000 multiplied by the design velocity divided by the SSD plus length of wheelbase. This combined value is your face headway. So let us calculate the SSD value. We have studied this equation as divided by V divided by S. So we have written S value as 0.2 times small v plus L, or 0.7 times capital V plus L. We have written this S value, the space headway, in these two equations. So we have L as the length of headway, and this is the approximate value. This is the approximate value of your SSD. Now, as all the values are given to calculate SSD, we will not use this approximate value. We will calculate the SSD. What is SSD? SSD is this. V value is given in kilometer per hour. Let us write it as into 0.5 seconds plus 0.278. You can write it as 0.278 in multiplication, or you can write 3.6 in division. You can solve it with me. The calculation will be this is coming out to be 86.78 meters. Okay. So let us put the values in the formula. Qmax equals to, or the capacity is equals to 1000. Why we have put this 1000? Because the denominator is in meters. This SSD value is in meter, the L value is in meter. In order to convert these values in kilometers, because the value is asked, or the V value we are putting is in kilometer per hour. To cancel out this kilometer, we want a kilometer in denominator. So we are converting this by dividing it, or by multiplying the whole equation by 1000. Multiply by 65 divided by 86.78 plus 5. This is equals to the answer is coming out to be 708.21 vehicle per hour per lane. The nearest answer for this question is this. So this is one value, or one process to calculate the capacity. This is known as basic capacity. If you are asked in a question what is the equation of basic capacity, this is the basic capacity. You can also use basic capacity in terms of time headway. In terms of time headway is P600, because time headway is generally given in seconds. This is your time headway. In terms of space headway, it is, this is your space headway. We have discussed these things in the lectures. Okay, so this is the last question, and it is about your rotary or roundabout. Roundabout. It says that it provided, a roundabout is provided with a average entry width of 8.4. So E value, we have average entry width as this. Width of waving section, the W width of waving section is given as 14 meters. We have length of waving section between channelizing island. You know that if this is your rotary, these are your channelizing islands. This length between your channelizing island is length of waving, or length provided for waving. This is the width W. This is your entry width E. What is your L? L value is given as 36 meters. We have the crossing traffic and the total traffic. So we have P value given as 1000 divided by P value is actually proportion of the value which is crossing this section. In terms of PCU, the nearest rounded capacity of the roundabout is. So we know that formula of capacity is this is the formula for capacity. Go to the formula if you find any problem. Now let us put all the values which we have in the question into this formula. Let us write it as 0.5. What is W? W is 14 divided by 36. So this is the complete formula. Let us calculate the solution and write the solution. My solution is coming out to be 73, 3763.2 PCU per hour. So the nearest answer I can get is 3700 PCU per hour. So these were the questions which we can find from traffic engineering. I think from today's problems I have covered all the topics. This is a revision class. We have revised many concepts and many formulas from this question solving session. I hope you have liked this session. If you want more session like this, you can write in the comment box. We will make more questions and we'll discuss these questions with you. So for now, thank you so much. Again, do these questions from yourself. Thank you so much.